So today we're going to be factoring special cases. The special cases we're going to be looking at are differences of two squares and groupings. Let me write that down for us really quick. So the two special cases that we're going to be looking at, one of them is going to be the difference of two squares, which looks like this: a squared minus b squared. So that's usually the way the problem looks, like some number squared minus some number squared, or a term squared minus a term squared. And you automatically, like magic, just write this. Okay, so I'll walk you through this. It's one of the easier ways to factor, but it only applies when you have a difference, so a subtraction, of two things that can be squared. Okay? So if you have a difference of two things that can be squared, then you can do this really quick one-step process and you're done factoring. So difference of two squares is kind of nice. Now, second one is going to be the grouping. So factoring by grouping. And usually, factoring by grouping involves four terms. So you're going to notice it because there's normally like an ax cubed plus a bx squared plus a cx plus a d. Four terms. Okay? So those are the two things we're going to focus on. Now, factoring by grouping isn't terribly difficult, but it looks complicated at first. Like once you get the hang of it, you're like, okay, this isn't that bad. But at first you're like, why are we breaking things up into parts and what's going on? So it is a little weird, okay? But once you get the hang of it, you should be okay. The very last two problems on your homework, so there's 12 problems on your homework, the last two problems are review problems from yesterday, okay? So they're both trinomials. That means they want you to do the x method for both, okay? One of them will have a equal to 1, so that's the easier ones. One of them will have a equal to 25. That'll be the ones where you got to divide at the very end, okay? So just to let you know, there's really just 10 new problems. The other two are just review, okay? So let's go ahead and start off with the difference of two squares portion, okay? So this is example number 1. Factor. I'm going to put difference of two squares, just so you know, like, okay, these are the ones that have the difference of two squares. And then I'm going to put a little hint right here, okay? I'm going to put GCF, meaning, remember to always look to see if they have a number in common or a letter in common that you can take out. Okay, always check for that. Don't forget, because if you forget, then you end up with really weird questions and you're going to be like, I don't understand how to do this one. Okay, so I'll do one of those for you so you can see, like, it looks impossible, but then when you factor something out, it's fine. But we'll do one of those. So let me start you guys off with something on the easier side first, as usual. So the way you know that it's a difference of two squares, or at least that you have a chance of getting a difference of two squares, is first off, you notice it's only two terms. So notice x squared and 25. And then you notice that there's a minus in there. So that's a difference of two things, right? A difference of two things. Now I want to ask myself, can I write those two things as squares? So this is my job here. Can I rewrite that as something squared minus something squared? Okay? How can I rewrite x squared as something squared? X, right? That one's pretty easy. It's just x. X squared. How can I rewrite 25 as something squared? 5. Now, excuse me, that's the hard part. So, here you go. X 5, X 5. Notice I just put the x's in the front, the 5's in the back, and just put minus, plus, and you're done. That's it. All right, so let's try a different looking one here. Same idea, just a different look. We'll try 9x squared minus 4. So notice this time it's not just an x squared. Okay, there's a 9x squared there. And then there's a number in the back. So I notice there's two terms and a subtraction in between. So I say, oh, that's a difference of two things. Can I rewrite those two things as something squared minus something squared? So what squared is 9x squared? A 3x, all right. What squared is 4? 2. Now before I move on, I forgot to do this in the very beginning. Remember I told you don't forget, but sometimes you do forget. 9x squared minus 4, do they have anything in common? No, right? They don't have any letters in common. They don't have a number that divides them both. So I didn't have to factor anything out first. So that's good. Nothing went wrong with it. But remember to always check. Anyway, we got 3x quantity squared minus 2 quantity squared. So our next step is just to write two parenthesis sets. I'm going to put 3x here, 3x there, a 2 here, a 2 there, minus plus, and I'm done. So relatively quick. Okay, they're relatively quick. All right, so let's try one more thing here, and then we move on to the grouping ones, because this is pretty much as well. What I'm about to show you right now is pretty much as hard as it can get in terms of difficulty by factoring. So just in case you forget to check for the GCF, which I'm going to do, but in case you forget, all right, this is what's going to happen. So don't write this down really quick. Okay, don't write it down. This is what you would do normally. And then you'd ask yourself, okay, what squared is 50r squared? Is there a number that I can square that gives me 50? No, right? Is there a number that I can square that gives me 18? No, right? 3 squared is 9, 4 squared is 16, 5 squared is 25. So I guess this isn't a difference of two squares, at least not yet. So then I say, well, maybe they have something in common. Do they have a number that can divide both of them? A 2. A 2 will divide them both. Is there anything bigger? I mean, what divides 18? 18, but 18 doesn't divide 50. 9 divides 18, but 9 does not divide 50. 6 divides 18, but it doesn't divide 50. 3 divides 18, but it does not divide 50. 2 divides 18, but it doesn't, actually no, it does divide 50, right? And 4 does not divide 18. But yeah, so 2 seems to be the only one. So let's take it out. So this would be 25r squared minus 9. Now again, I'm going to focus on just this now, okay? Remember, that 2 is still out there, but my focus is on the inside. So I'm just going to work on this. Can I rewrite the inside as something squared minus something squared? Like, what's 25r squared as something squared? 5 what? 5r. And what's 9 as something squared? 3. So look, I'm just going to do this now. My two parentheses, but then I'm going to say, oh, don't forget that 2. That 2 in the very front has to come down. Okay? I kind of draw a little dotted arrow there, or dashed arrow, so that you guys can see, like, oh, that came from there. And then I'm going to write 5r, 3, 3, and you know what? I'll break my rule, plus minus. I don't like the way it looks, but it is not wrong. Okay? So notice, I still was able to do the difference of two squares. I just had to factor something out first. Okay? So I just did 3 out of the 6 problems that are difference of two squares. Now we got 4 more problems to worry about. They're both on grouping. I'll do 2. And then that means you just have 2 more to go, and you have 5, 6, 7 problems. 5 will be new. The other 2 will be review. Okay? Are we okay, though, with the difference of two squares? Now, people have asked me before, can you do a difference of two squares? Like, for example, let's just do part A. Can you do that using the x method? What if I forget how to do the difference of two squares? Can I do the x method? Check this out. You can. Okay? What's my b term? It's x squared minus 25. Isn't minus 25 my c term? Right? What's my b term if it's not there? A 0, right? It's 0x. Okay? That's what my b term is. It's 0. So I'm supposed to multiply a times c. That's 1 times negative 25. That's negative 25. What do I put on the bottom? 0. What two numbers multiply to negative 25 and add up to 0? Well, if they add to 0, they better be the same number, right? Just opposites. So negative 5 and positive 5. These are my answers. X minus 5, x plus 5. And look at that. Same answer. Right? You can do it by using the x method. You may not want to because you got to get creative and say, wait, where's b, right? So you got to say, oh, that's a 0. If you forget to do that, then you're in trouble. You got to remember that. But it can be done the old-fashioned way. All right? You may just not want to do it. Okay, I wouldn't. If I know it's a difference of two squares, there's no way I'm doing x method. I'm going straight to that little magic trick and I'm done. Okay? So, by the way, it's not a magic trick. Is that what happened is people noticed that for every single one of these things that look like this, when they would do the x method, it always turned out to be the same numbers minus plus, same numbers minus plus. So they're like, oh, there's got to be something to this. Then they developed the definition, right? So they didn't just guess. There is math theory behind it, okay? It wasn't just a crazy guess and, yay, we got it right. No, they actually worked through it. If you do decide to major in mathematics, and I know you might be saying like, yeah, right. Most students say that. You'd be surprised how many of my old students have come back. I think so far I'm at 5. In the past 5 years, 5 kids have come back and said, I'm a math major. And I'm like, you told me you hated math. They're like, yeah, I don't know. I liked it once I got to college. And I'm like, that's what happened to me. Like, I hated it in high school, but I loved it when I got to college. It was really different. So, but who knows? Maybe one day you'll take number theory, which is what helps you with this stuff. So, anyway, we're going to factor, but this time we're going to use grouping. And remember, I'm going to put this little hint right here again. You may want to do the GCF if possible, okay? But looking at your problems, you're not going to be able to take out anything using the GCF. But I'm just telling you, GCF should always be first, okay? Always ask yourself, can I take something out, all right? So again, we're going to do 2 examples. Now, there is no formula for factoring. There is a process, so I'm going to kind of show you guys that process right now. So let me write down the first one here. 3x squared minus, 3x cubed minus 2x squared minus 9x. Oh man, do I really want to do that? Yeah, I'll do that. Plus 6. I was just looking right now and I'm like, oh, these are all minuses. So that's okay. So you're going to have 4 terms. That's your big clue that you have grouping to do. Okay? So step 1, and it's a tricky step, okay, but it's not really tricky, but there's a little thing that you can mess up and get things wrong. Step 1 is you're going to put in parentheses, okay, for the first 2 terms and the last 2 terms. But if you just do exactly what I did, I'm going to put right here, number 1, parentheses. But I'm going to put little asterisks or an I don't know, just like an eyeball, okay, like So watch out, okay? Watch out. When I put that parenthesis on the second set of numbers, the 9x plus 6, you need to change the symbol. Okay? So I'm going to put change sign in second parentheses. Now, why do we change it? Because there's a minus right here. If it was a plus, you don't change it, okay?
Isn't the 3x squared be 3x cubed?
Oh my gosh. Thank you. I did it again. All right. Hold on. For some reason, I know I said I did it the first time. I said, oh, I messed up, and then I fixed it, and then I did it again. Thank you for that. But that minus sign in the middle, if you put the two parenthesis sets and there's a minus in the middle, you better change the sign in the second parenthesis. If you don't, you're going to get everything wrong. How do you know you get it wrong? It'll happen in the steps, okay? So I'm going to kind of do this really quick. Kind of like make that go away. All right, so we have a minus there. Okay, first step, put parentheses around the first two terms, second two terms. If there's a minus sign in the middle, then change the sign in the second parentheses. If there's a plus sign, you don't have to change anything. Okay, but if there's a minus sign, you gotta change the second one. Okay, and how do you know you messed up? It's gonna happen in the very next step. I think the next step. So here we go. Now, for the second step, factor each parenthesis. So what can I factor out of 3x cubed minus 2x squared? Do they have anything in common? Hold on. You're saying 2x, but do you mean x squared or the actual 2? X squared. Okay, they do have an x squared in common. One has 3 x's, one has 2. So I can take 2 of them out. Do they have any numbers in common? A 3 and a 2, do they have anything in common other than a 1? No. So just an x squared. So here we go. Let me take out an x squared. And what's left on the inside is 3x minus 2. All right. I forgot my x squared. X squared, and there's a 3x minus 2. All right. What does 9x minus 6 have in common? A 3. Do they have any letters in common? No, right? No letters. I mean, 9 has an x, but 6 doesn't. So just a 3. If I take out a 3, I end up with 3x minus 2. I want you guys to check this out. You see how this came out the same as that one? If that happens, you know you're doing it right. If your parentheses match, you know you're doing it right. If they don't match, that means if it would have said 3x plus 2, then you know you forgot to change the sign. Okay? That's how you know that you forgot to do the sign change. All right? So notice that yellow part that matches. What I'm going to do is I'm going to write the highlighted thing by itself right here. So it's going to be step 3. Factor GCF. Again, because that's what we did right now. Okay, this would have been GCF. We're going to factor the GCF again. The greatest common factor, the common thing that they had is that thing in yellow. That's what they have in common. So take it out. What's left over? If I took out the thing in yellow, if I made that thing in yellow completely disappear, what's left? So just pretend that highlighted thing doesn't exist. What's left there? You don't see an x squared that's not highlighted? You guys see it right here? And this minus 3 right there? You guys see those? That is what's left over. And I'm done. That's my factor. Now, some people might say, wait a minute, x squared minus 3. Isn't that a difference of 2 squares? Well, can I write x squared as something squared? Yeah, it's x squared. But can I write 3 as something squared? No. So then it's not a difference of 2 squares. So stop. You're done. Okay. Now some people are going to argue, yeah, you can. Radical 3, square root of 3 squared is 3. Well, yeah, that's great, but we're not going to do that. Okay, we're not going to that point. You want to do that, we'll take trig, and you can do that. So remember, the most important part, you better have matching parentheses. If you don't have matching parentheses, you did something wrong. Go back and check to see what you did wrong, because they got to match. They got to match. If they match, you know you're on the right track. You take out the matching portion. Okay? So kind of like doing one of these things, right? You're gonna take it out. It's gonna disappear, and the only thing left will be the x squared minus 3. So you write that as its own parenthesis. Okay? And then you're done. So this is called factoring by grouping. So this is one of your homework problems. Let me do another one. I mean, they all pretty much look the same difficulty. Actually, number 8 looks like it's the easiest one, so I'm not going to do that. We'll work on the ones that look a little bit more challenging. So 2n cubed minus 6n squared minus 3n plus 9. Remember, it should have 4 terms. Okay? It should have 4 terms. I'm leaving the instructions up there for now. The things that I wrote. Actually, if I can, let me see if I can copy paste them through the wonders of technology. Copy and paste. All right, there we go. You guys don't have to rewrite it if you don't want to. I mean, you have it in your notes already. But I just want it to be visible to you. All right, so first thing I got to do is introduce my parentheses, right? So it's going to, let me write 2n cubed minus 6n squared minus 3n plus 9. And I'm going to put parentheses around the first 2 sets and the second 2 sets. But look what it says. Number 1, put your parentheses, change sign in the second one if it's negative, right? So is it negative in the middle? Yeah, so then that means I better change that plus to a minus, okay? I better change that. Now, if it was a minus on the second parenthesis, then make it a plus, okay? So, but make sure you change the sign. If there's a plus in the middle, don't worry about it. Okay, next step says factor each parenthesis, right? Using the GCF. So what does 2n cubed minus 6n squared have in common? A 2 and what else? An n squared. So 2n squared. So what's left over? Well, it's going to be an n minus 3. Because 2n cubed divided by 2n squared, there's only an n left over. And then 6n squared divided by 2n squared, there's only a 3, because 6 divided by 2 is 3. And the n squareds will disappear. All right, what do I factor out of 3n minus 9? A 3. And if I factor out a 3, I end up with n minus 3. Did I do this right? How do I know? All right, the parentheses are matching, right? If this happens, then I should be happy because that means I don't have to check my work. So far, so good. All right? Last step, factor out your GCF again. In this case, I'm talking about the highlighted portion. If you want, I'll even highlight it like this to remind you. Like, that's what I'm talking about. That's your GCF. Okay? So, I get n minus 3. That's what's in the highlighted region. What's left over? All right, 2n squared minus 3. Now, does the second parenthesis look like a difference of 2 squares? Kind of. Can I write 3 as something squared? No. Can I write 2n squared as something squared? A 2. No, there's nothing that I can square besides a radical 2, but we're not doing that. There's no, if I square 1, it's 1. If I square 2, it's 4. There is no square for 2. So that means I'm done. So grouping isn't like, oh my gosh, this is so difficult, but there are steps that you have to follow, okay? And there is a specific step when you know that you're right. It's that highlighted one where you look and you're like, oh yeah, this makes sense because they're identical, right? So you know that you're right because of that. Okay, if yours don't match, something's wrong, go back and check. Okay, unless you didn't do anything wrong and it's not factorable, which can happen, but I don't think any of these 4 problems have that situation. But it can happen where you try doing it and it doesn't work. Okay, and that's okay. But that's not going to happen in our homework. All right, so that's what your homework is today.